The physical on-disk order of rows in ClickHouse merge tree tables is defined by the order by key. The order by key and physical row order improve compression by co-locating data in column files. In this video, we're going to look at a new setting introduced in ClickHouse 24.6 called optimize_row_order. If you apply this setting, ClickHouse will still sort data by the order by key in those files, but after that, it will automatically sort the table rows by the remaining columns based on their cardinality. And this should lead to improved compression. Note that this optimization is only applied for data parts created at insert time. It doesn't apply when parts are merged later on. Let's have a look at how this works. So we're going to launch ClickHouse Local, and I've got an existing database. So we're going to switch over to that. So it's called PyPI. And then we'll have a look at the tables. So you can see I've got two tables. We're going to look at one with the setting applied and one without. Let's show create table on PyPI. And then we'll scroll to the top. So you can see this is a table that's going to capture information about PyPI downloads, the popular Python package manager. And if we scroll to the bottom, you can see the settings. We've just got the index granularity set, and it's a merge tree table, and the table is ordered by project. If we then update that command to put opt on the end, if you go to the top, we can see it's exactly the same fields. And as we come down to the end, again, merge tree table, ordered by project, but this time we've got optimize row order set to 1. We're going to import some files that contain PyPI downloads. Now this dataset has 1 billion records, and if you want to see the full billion record dataset, we're going to link to the blog post below. I've downloaded 50 million or so rows onto my machine. So let's now write a query to insert into the PyPI table. So this is the one without the setting. We'll select from those Parquet files, and then we're going to set the minimum block size to be 10 million rows for maximum compression. And let's get that, kick that off and have it running. And we're going to speed things up because this takes a little while, and you can see it finishes. It's taken 42 seconds to process just over 49 million rows. Let's now update that query to do it on the opt table, and we'll kick that off and have it running. Everything else is the same. Remember, the only difference is we've got that setting on this table. So we're going to speed it up again, and you can see it eventually finishes, and this time it took 86 seconds. So it was a little bit over double what it took with the other one, which was 42 seconds. Now, usually we'd expect to see it to be 30 to 50% slower. So it was quite a bit slower than that on my machine, which is interesting. Now let's have a look what the compression looks like. So we're going to query the system.parts system table. We're going to get back the table. We'll compute the number of rows. We'll get back the uncompressed size and the compressed size, and then the ratio between the two for tables that start with PyPI. So you can see PyPI is 1.25 gigabytes compressed. PyPI opt 1.02 gigabytes compressed. So it's about a 20% space saving. When we did this with 1 billion rows, we saw a 30% saving. Again, link in the description below. If you're interested in more stuff about compression in ClickHouse, check out this video here where we looked at the greatest common denominator codec.